Hello. In this session, we're going to look at component design software for structural masonry design. My name is Sam Rubenzer. I'm the founder of Force Consulting and the managing director. I'm a licensed structural engineer in the state of Illinois and a professional engineer in many Midwestern states. I have an engineering degree from the University of Minnesota and an MBA from Marquette University. Here at Force, we are a team of engineers with extensive masonry design experience. We've been consultants to the masonry industry since February 2010. And we've created a lot of papers and presentations for sharing knowledge on software and structural masonry design. In this session, we are going to look at several different masonry software programs. We're going to learn about different types of masonry software programs, kind of what they are, when to use different types of programs. First ones that we're going to talk about in this session are going to be component design software. We're going to look at some of the different features of component design software programs. We're going to discuss what would be appropriate for what we call component design software and what would not be. There's going to be times when we have complex designs that maybe wouldn't fit within a component design software tool. And then we're just going to look at some of the different summaries of features for several different component design softwares. I do like to talk about the different engineering workflows that we have between different materials. I talk about this from steel design and concrete design, what the typical workflow would be when you need more strength, what different options you have, but certainly all these different variations in design. We do use commercial software for both steel and concrete design, and I'd like to bring masonry into that same design flow, where we actually use commercial software to do masonry design for some of the very same reasons. I would consider it the wrong way to just look at some minimum design, some rudimentary tools, and then move on with our design. We have a lot of different options that we want to choose when we look at steel and concrete design, and commercial software certainly helps us make the best choices for those different materials. And I would say for the very same reasons, if we want to be efficient with our use of materials, if we want to consider complex analysis and design options, we really need to have tools that are robust and can handle a variety of different conditions for design. When we look at commercially available software for masonry design, one of the first questions that people ask is, do all programs or do all masonry programs use finite element methods and analyses? And that certainly isn't the case. In fact, what we're going to be covering today would be the component design programs, where you simply have different elements within a design that can be isolated, simple analysis, and the primary focus of the program can be on the design attributes of the program. So these programs make a lot of assumptions. Sometimes that's okay. Sometimes masonry can be more complex, and we actually need to make sure that we verify things with a finite element model and analysis, or actually move the design of an analysis and design of an element to a finite element model and design. So just holding the two different types of software side by side, finite element modeling and analysis is really going to allow for a much more complex approach. And with that complexity does come the demand for a much deeper knowledge of the materials, much deeper knowledge of the details and conditions into which the masonry wall is going to be used. For instance, if the base of the wall is going to be fixed, and or if there's some partial restraint for the top of the wall, all different things that would be relatively complicated to model outside of a finite element analysis program, or looking at both vertical and horizontal bending within one wall panel. Maybe we need to find an element model and analysis to look at that. So there's a lot of masonry walls, though, that would allow for a more simplified approach. Certainly you could choose the complex approach, but it's really not going to be any more advantageous for the design. There's going to be a point of diminishing returns. For instance, for a lot of different types of designs, maybe 80% of the design could be covered with a component design software, and just some specialty cases would be needed to use a finite element modeling and analysis. So masonry elements are components that are interconnected. Sometimes we can make some assumptions, again, to be able to cover accurate enough results. Component design softwares are going to tend to be a little bit more conservative, a little bit less accurate. Sometimes that's okay. But like I said, sometimes we do need a little bit deeper dive and further analysis. Just to give you a quick reference here to the different types of softwares that I'm talking about, what I would consider component design softwares would be software programs from the Concrete Masonry and Hardscapes Association, ELEMASONRY, and Direct Design. Those are going to be two programs that really do look at individual components from the analysis and design perspective. We would have TECLA-TEDS, another program that would be able to look at individual components of masonry design. IES QuickRWall is actually going to be the same program as ELEMASONRY, so we'll talk about those two programs a little bit later on. IES also has another program called QuickRWall, which is going to do a retaining wall design. So it's a nice program that has some masonry design options for retaining walls. ENERCALC is going to be, again, one of those all-inclusive tools, just like TEDS, where it's going to cover a variety of different steel and concrete, wood and masonry design options. So you can have that one tool that's going to be able to cover a lot of different programs. There's certainly other programs that are out there. These are going to be the ones that we're going to focus on today, and not to diminish the spreadsheets that you've all created. Those would certainly be component design software. Generally, they don't have a finite element, a model component to a spreadsheet, so I'm going to put that in the component design software category. Some of the programs that we use for masonry design here at Forest would be RAM Elements, where we'd be able to have a finite element model either in the general program or in the RAM Masonry module. Both would be kind of finite element based in terms of the analysis and load distribution in the actual design based on that finite element modeling. RISA Floor, RISA 3D, going to be another finite element program that's going to be able to do that analysis. Tekla Structural Designer is going to be a little bit unique in that it's going to have a finite element analysis for masonry elements, and you're going to be able to define those elements very specifically within the Tekla Structural Designer, but it's going to do the analysis, and then it's actually going to send the section information from the analysis to TECLA-TEDS to do the design. So it's kind of a combination of the two. You use the Tekla Structural Designer for the heavy lifting of the finite element analysis, but then send those section forces to TECLA-TEDS to do the design within the component software. So it's kind of a combination solution, which I think is very unique and actually very useful for design. Just to give you a little bit of a graphical representation between the two different types of programs. Again, component design software, as I've said, is really looking at individual elements one at a time, kind of taking a wall, even a simple wall like this with a standard opening, and actually breaking the wall into pieces so that you can have just an individual force set that we can do a very rudimentary analysis and design, versus the finite element approach, where we would keep all of the masonry elements interconnected and allow for the forces to flow both vertically and horizontally through these different elements, and we can track the forces certainly for all the different elements in all the different areas of the design. To talk about it a little bit more specifically, if I take the component design approach, where we have several different areas that we would want to focus on, I just call one here kind of the common wall area, where we would look at just the typical wall design, mainly spanning vertically between, say, a foundation and floor or roof diaphragms. We would primarily have axial and flexure loads. We maybe have out-of-plane and in-plane forces that we have to design for, but pretty much the standard wall. Again, one here is relatively small area, but one could be several hundred feet long. It's just going to be the general typical area for a design. Anytime that you do have an opening, though, you can see the wall area number 2. What do we have to do with that wall area? If we're using component design software, we really have to make a decision. Does it span vertically or does it span horizontally, like we can see in the image. I would probably choose to have that span horizontally, look at the reinforcement, maybe joint reinforcement to see what the span would look like for that element just in the plain horizontal direction. So you generally have to make the decision. You can't have a two-way spanning element. Typically with component design software, we have to choose either vertical or horizontal. So right away you can kind of see some limitations pop up. You look at item 3, the jam element for an opening. Again, this area is going to be, you can see it with a red stress concentration there. With the component design approach, you really have to lump a lot of the load from the opening and then maybe the areas above the opening and the lintel and the wall area too, just to the jam area to resist that vertical span and bending. So what it ends up happening is that element tends to be very heavily loaded, much heavier loaded than the standard typical wall area number 1, and you'll see a very high concentration of reinforcement and so on with the wall areas, the jam areas number 3. So again, that can be a very critical element and a lot of force that would be defined within that area because of the limitations of the analysis approach. The lintel, another element that's going to be, again, somewhat conservatively, somewhat unconservatively viewed, and I'd say conservatively from the typical lintel perspective of looking at it as a pin-pinned condition, assuming that the support would be somewhat isolated from the lintel itself. So looking at that, we would be conservative with a positive bending moment, but we would be unconservative for the negative bending moment because, again, not looking at the fixity that the lintel truly has with the wall areas on each side. We have right away an unconservative approach, and then looking at horizontal spanning, we have a lot of different decisions that we have to make and understand about how the force is going to get distributed through that lintel. Again, some of the different programs are going to give us both vertical and horizontal span calculations that we can do. Some of them are just going to be looking at just the vertical span. Other options that you do have with component design software is, again, you could use just the design portion of component design software. We can maybe model the wall with a finite element analysis model. If we think that this is a wall that we really should be looking at is an interconnected element, maybe we do a finite element analysis model. You can see all those different wall areas, 1, 2, 3, and 4, now having the ability to connect with one another, share load with one another, so that we can have the forces being distributed maybe a little bit more accurately to how they would actually be distributed to a real masonry wall in the field. So again, getting all of those elements modeled and then extracting the results. We do have some papers that we have available for giving some suggestions, but typically this is going to be dependent on the finite element analysis that you are utilizing. It's going to be a little bit different process for how you can extract some of those results from the finite element analysis to the component design software. So again, it doesn't have to be all one or the other. You certainly can use finite element modeling and analysis and then use your component design software just for the design features, which would be something that we would strongly recommend if possible. To give a little bit of an animated description of what we're looking at here, again, if you look at the models and how they would actually deflect out of plane, we've magnified the actual deflected shape so you can see the point that we're trying to make. If you focus on the red areas in the component design software, as I go to deflect the shape, you can see that those red areas, because of all of the load and stress, you'd actually see that section deflecting out of plane relative to the other elements that are around it. So we know that in reality, we don't have a jam area that deflects more than the area above the opening or the wall area on each side. We know that instead of deflecting more, it would actually distribute the force more. And again, if we look at it one more time, and if you want to watch the model on the right, you can see that everything flexes together and shares load together, and that's really going to be a good representation of how a masonry wall would actually work. So we know that there's good reasons to consider finite element models and analysis, even for something as simple as an opening. We also know that there's a point of diminishing returns. There's sometimes it would be a little bit more accurate, but it's not sufficient enough to actually make the change from a component design software, which again are a lot easier to use, to the finite element approach. Really quick example, if I look at a couple different tools here, RAM elements for a finite element analysis for that same kind of model with the standard door opening, we can see some of the different stress concentrations. We can also see how the moment curves and contours are going to flow across the section. We can see that there's not a super high stress concentrations. There's some right near the corners, but it's not going to be extremely high relative to the areas just adjacent to it. And so in fact, when we look at the reinforcement, we can break down the wall into different strips. So kind of looking at it in the similar approach that I described before with a typical wall section, a jamb area, an area above an opening, and then you can see lintel reinforcement that would be selected as well. Just kind of a quick comparison so you can see what some of the differences could be. So you can see the typical wall, we actually have a little bit more efficient use of reinforcement. With the finite element analysis, this had to do with a fixed base that we considered and a parapet that was able to be utilized. Not all component softwares have fixed bases and parapets that you can consider. So you can see right off the bat how you could be a little bit more accurate and a little bit more efficient with the use of materials. You can see the jamb reinforcement is far, far less. We have one number 4 bar versus the jamb reinforcement in the component design where we'd have 6 number 4 bars. So quite a bit of difference for the jambs. And then the lintels also, you have a couple different options for the component design software with arching action or without. And some of the reinforcement that you would have that can be comparable to finite element analysis, or again, without arching action, you'd have a very heavily reinforced lintel. So with that, we know that there can be some value to using finite element analysis, or certainly utilizing some of the understanding that we can gain there to make maybe better decisions as we try to choose and use component design software tools. But if we back all the way up, we know that there's a lot of masonry elements, in particular partition walls. So here you can see a spreadsheet that we've developed at Force for doing partition wall design, and there's a lot of different spreadsheets that anybody watching this could certainly develop a spreadsheet for partition wall design and do that design for what is a very simple materials and loading that you're going to have on partition walls. So we do recognize that component design software is plenty, more than enough for what you have for a lot of different masonry designs. In fact, other component design softwares like Direct Design is something that we utilize on a regular basis as well. Here you can see a school where we have a gymnasium that we're looking at providing a design for the gymnasium, and we can see that, well, it's going to be a big box. It's going to be a big rectangular box with some small parapets, single story, wall spanning, and we're going to have some regular movement joints. We have a couple openings within the elevations, but really Direct Design is going to, component design software is going to give us all the reinforcement and all the different, options that we need. We really don't need to use something that's any heavier, any more complicated than Direct Design for this gymnasium. Now, on a similar project, we look at another building that's got a school that maybe, like this design, we'd use Direct Design software for almost all of the school and all the different walls. We knew that we had a fairly good approach to that design. But then we had one elevation that we had, I think this was a science teacher that wanted a little bit more light in his classroom, and he wanted a little bit larger opening. So we know that we could have designed that with a component design software, but using finite element analysis really gave us a much better understanding for what the actual analysis and design would be for that one elevation. So sometimes you use component design software, sometimes you're going to use finite element analysis software, or a combination of the two for the varieties of different types of designs. Tips for using software. I think one of the very first things that we do within software programs is take a look at what the actual initial values are for a lot of different settings within programs. Sometimes people assume that some of those initial values are defaults or are industry standards, I should say, and really they're not. They're working within the software industry. I know that a lot of those values were just selected based on what the programmer typically had used, recognizing that they're all values that can change and should change depending on the different areas of the country. For instance, we know that masonry strength of materials can be different on the East Coast than in the Midwest than in the West Coast. We know that there's a variety of reasons why you maybe would want to use lower strength masonry and a variety of reasons why you'd want to use higher strength masonry. So whatever the F'(M) is that you have when you open a software program, recognize that you should be changing that dependent on the project, depending on the element that you're designing, to make sure that you're getting the most efficient, best design, and you don't just stick to whatever the software program had defined initially. We also look at complicated walls and all the different things that we have going on there, making sure that when you use software, you're really not oversimplifying a complex design. Like we talked about with the science teacher that needed the big window, we don't want to force that into a component design tool. We want to use a finite element analysis tool, but there is a point of diminishing returns and plenty of times when we can use component design softwares. If I do a quick comparison, if I look at a lot of different software programs at once, what I'm going to do is try to compare and contrast, how the different programs approach and utilize the different elements. What are some of the different options that we have? So we've talked quite a bit to this point about finite element analysis versus component design calculations. A lot of times the biggest difference there is obviously going to be in the analysis that's done. Everything that we're doing in this session is going to be focused on the component design, simple analyses, but really when it gets to the design, both finite element analysis and component design softwares can have very similar approaches to the design if we break it down between design and analysis. We know that different programs have different attributes for wall designs, vertical wall designs, partition wall designs, in-plane shear wall designs, perforated shear wall designs, lintel designs, pilaster designs, and column designs. So we'll give you what some of the different options are there. Some of the different material options that you have. All the different programs have a little bit different way of entering in the masonry materials. And again, with the 3 different concrete components that you have with concrete masonry, you have block, you have mortar, you have grout. All of them seem to have a little bit different way of entering in that material information so that we can do masonry design. So we'll talk about that for a few of the programs, at least today. We'll look at some of the different loading conditions and support conditions across the different programs. Again, that can make significant differences in the overall forces that you're designing for. So making sure that you have appropriate loading options and support options within the different tools that you're using for design that you're selecting. Happy to say most programs today do give us pretty similar options between allowable stress design and strength design. If we go back into the older codes, if we needed to check something based on, say MSJC, 2011 or 2008, maybe we would have a lot of softwares that would just maybe have allowable stress design. But given today's code, the 2016, 2022 codes, most of the programs are going to have equal kind of support for ASD or strength design. We also talk a little bit about some new technologies, how some of those might be implemented within the different programs with some of the different material selections that you can make for the designs. So when we, again, talk about material options, we know that we have block sizes, we have different thicknesses that can be selected. Some programs limit the wall thicknesses that it utilizes. Again, it's generally not something that is anything other than a programming limitation. We know that we can have concrete masonry wall thicknesses of a variety of shapes. And so we know that we maybe need to enter in also some custom shapes. So we'll talk about maybe which programs you can do that with as well. F''M, the strength of the assembly. We know that, again, sometimes we want to just enter into F''M, the strength of masonry. Other programs, some programs just allow us to put in block compressive strength and mortar type and mortar categories. So different types of mortar that we have obviously type M, S, or N. Within the different programs, we know that we have Portland cement lime that we can choose. We have masonry cement, mortar cement, which is going to have the more tensile capacity, or masonry cement, which would be a little bit more common. We know that all of these values are things that we can enter. You're going to notice that really none of the different software programs ask you for what the grout strength is, because the grout strength needs to be the same as F''M or greater. So it doesn't even choose to ask you what the grout strength is. It focuses on sometimes block and mortar, sometimes just the overall F''M, but none of them are going to ask us for the grout strength, because it really is a dependent variable that we have to sort out in the project notes. So we don't enter that into the software programs. It's really going to be something that's going to be coming along for the ride once we define F''M, mortar types, so on and so forth. And again, really want to emphasize this point: don't use the original defaults. Reset them based on what's going to be realistic for the actual project that you're in, elements within the project that you're designing. Again, some of the different programs that we're going to step through and look at some of the different options. Again, we're going to look at the ELEMASONRY and direct design programs from CMHA. We're going to look at the Tekla TEDS program, some of the different options that it has available as well. We're going to talk about IES QuickMasonry and QuickRWall. QuickMasonry is going to be the wall design program that's going to be similar to ELEMASONRY. The QuickRWall is going to be a retaining wall program, which again is going to look at the foundation footing, the toe and the heel of the footing for sliding and overturning and so on and so forth. But it's also going to look at the stem wall design in masonry that we can choose for designing of that element. We'll look briefly at ENERCALC and see what some of the different options that are there. And again, your spreadsheets would certainly be part of the component design softwares. I'm not going to talk about your spreadsheets. You know what your spreadsheets are, but that would be all within this category. Before we talk about some of the different software tools that are out there, I also want to mention some of the different programs that I've talked about on similar presentations that I think should be noted. The masonry partition wall design is no longer available from IMI. The program actually was took down and looking to be improved and updated and offered by the Concrete Masonry Checkoff. The Block Design Collective is going to have a similar and better version of the same program. So we're going to be able to do partition wall designs, but the old one is not currently available from the International Masonry Institute. The other program that I like to use that did get also sunsetted was the Structural Masonry Design System. It was a program that covered wall elements and lintel elements and a variety of different conditions. That actually got migrated over to the ELEMASONRY program. So the efforts that were put in for the Structural Masonry Design System, again, a lot of different features that were in there that I liked. I'd see a lot of those getting now put into the ELEMASONRY software program. So again, ELEMASONRY, we're going to mainly focus on ELEMASONRY, but ELEMASONRY and QuickMasonry are going to be the same program from the same developer. So again, we're going to see a lot of the same features utilized for both softwares. You don't have to buy both. I just happen to buy both because that's what I do. I look at these programs and evaluate them, make sure that they're the same, and you can see as CMHA and NCMA worked on and developed ELEMASONRY, you could see that then the programs kind of came into parallel and are going to be the same program going forward. So within ELEMASONRY, so the first things that we want to point out is just looking at the different sections that you have, the units, sizes that you can have. You can see masonry units from 6 inches all the way up to 16 inches available, all the different thicknesses, the actual thicknesses, the heights, the face shell thicknesses, the web thicknesses, all the different values that are going to be important for analysis and design. Next, you can see the different types of components that you can look at within ELEMASONRY. In the upper left, you can see the wall, the beam or the lintels that you can design. You can see masonry pilasters and isolated masonry columns that you can design. You can also see that there's some common criteria. So within the program, you can develop a whole list of different design checks that you can make. So all of them are going to be individual components, but all of them can follow the same common criteria. So you can see that down at the bottom left, where you can choose again the code, strength design, allowable stress design. You can also define the F'(M), so the overall strength of the masonry element, and then you can define the mortar type as well for anything that would be checked as, say, unreinforced tensile checks that would need to be performed on any of the different types of elements. Within the masonry walls, you can see that we have, again, more criteria that we can define that are particular to each one of the different wall checks that we perform. We then have wall criteria that we can define. We can define the height of the single-story wall. We can define the length of the wall. We can define the reinforcement spacing. We can define a singly reinforced or doubly reinforced walls. We can also look at the horizontal reinforcement. We can put in joint reinforcement. We can also put in bond beam reinforcement, define a parapet. We can then define different types of loading, pressure loading on the walls. You can define a uniform pressure. You can define a different pressure for the parapet. You can define, in plane loads. You have a lot of different loading options that you can utilize for this program. And then you can see the criteria on the far right, where you can have all the different checks that are going to be performed for the wall, for the different support conditions. Again, the support conditions here are going to be pinned at the base, pinned at the roof, but then you'd also have the opportunity to put in a parapet and a parapet height for the analysis and design. For the beams, again, we have the common criteria, but then we have more criteria that we can specify for beams. We also then have different spans that we can define. We can define a clear span from the vertical bending direction. We also have a horizontal bending direction that we can define. We can define its own span from the horizontal out of plane direction and a tributary height. We can put in a horizontal pressure load that we can design the lintel for. So I think that's a really important kind of unique feature here within ELEMASONRY. You can define different wall heights. You can define arching action or not arching action. You can also specify a reinforcement, top and bottom reinforcement, a different number of bars per row. You could look at the lintel for the shear capacity. You can see if you have maybe a limited depth lintel. You could also include stirrups. Anytime that we have shear considerations that we want to make, we would typically recommend increasing the depth of the lintel, except when you can't. Say you have a head of a door and a window that's going to be just above it that's really limiting the depth, or there's a variety of the conditions, then you certainly can include stirrups and improve the overall shear capacity design-wise. We also have deep beam reinforcement that we can have specified and checked for the beam elements. We then have the vertical elements of pilasters and columns, where we can again look at more criteria, more different loading conditions that you would have for pilasters and columns. You can also specify your vertical bars and stirrups for the column elements, so that you can check the biaxial bending capacity of these masonry elements as well. Next, we have the QuickRWall. Again, it was the retaining wall program that's from IES that looks at the retaining wall designs. It's going to look at, again, your foundation design. It's going to look at all the retained soil and stuff like that. But then you can also choose the material for the stem to be masonry. You can then set the F'(M) for the masonry at whatever the value would be appropriate for your design, and then it's going to see on the right on the bottom the actual stem checks, where it's going to look at the moment shears, base development, so on and so forth for the masonry stem element. Next program we're going to take a quick look at is the direct design software from the Masonry Society. Has the direct design handbook that really is a nice tool for looking at the designs that you would need for, again, the different components that you could have in a masonry building. So if you're able to have a relatively straightforward masonry building and you have a lot of different components that comprise of different walls that you have within the building, this tool can be a really great kind of straightforward method for matching up some of the different design tables that you would have in the direct design handbook with what some of the different loading conditions that you can specify in the design. So just taking a quick look at one of the initial screens here for the direct design program, you can see that we can define, again, the rectangular shape of the building, single-story buildings. You can define some openings and movement joints. The program is going to take and break apart all those different elements and do a lot of different component design programs all at the same time, which can be a really useful, powerful tool. Again, I've used it for anything that's going to be rectangular footprint. Even if I have multiple different column rows, if it's got a rectangular footprint and I have masonry on each side, it's a really great tool for doing the overall analysis. I can put in different loading criteria from ASCE, put into different, wind and seismic and snow and roof and dead load and live load and floor dead and live load, and it's really going to give us a lot of different criteria. So it's going to do a lot of number crunching, but at the end of the day, it is not a finite element analysis. It is a very good and efficient component design program that looks at a lot of different elements all at the same time. It's going to do a quick evaluation of all the different elements. It's going to show us what the design checks would be for the in-plane wall, the out-of-plane wall, the lintels, which again, the lintels are all going to be simply supported elements. But you could consider arching action. It's going to look at some of the different criteria for arching action and what would be prudent to do in that situation. So again, a very nice tool for doing fairly straightforward masonry buildings. Next, we want to look at TEDS. Again, we mentioned earlier, TEDS works also with Tekla Structural Designer. So the next session, we'll look at finite element analysis and Tekla Structural Designer and how that's going to work with TEDS. TEDS does work also as a standalone program. Here you can see you can specify the different elements, the unit strengths, the mortar categories, the mortar types. The program's going to then take, from those unit strengths and mortar types, it's going to give us an overall F''M. It's not going to ask us, again, what the actual grout strength is. It could ask us what the grout type is and the density of the grout, so it can get the weight of the wall correct. But again, it's not going to ask us for grout strength because that's going to be dependent on F''M or greater. It's going to ask us for vertical reinforcement details. It's also going to ask us for possibly horizontal reinforcement details. It's going to have a lot of different loading conditions that it's going to consider for the design as well. We can look at, again, all the way up to the TMS 2022 code, look at strength design or allowable stress design. Here you can see very similar options for masonry lintels. You can look at simply supported elements. We can look at the codes that we can choose here, again, all the way up to the TMS 402, 22 code. Design method could be strength design or allowable stress design. We can define, again, the unit strengths and the mortar types so that we can get an F''M for the strength of masonry. For the design, we can look at the different thicknesses, depth of sections, define our reinforcement within the lintel. It's going to do a bending check. It's going to do a shear check. It's going to tell us when we would maybe need to use and consider stirrups for the design. It's going to also do a deflection check for the overall design. One of the really nice things that it does as well is it evaluates the different options for analysis. It's also going to give us a nice little checklist for whether or not we can choose to use arching action. So I thought that was a very prudent thing for the programmers to include for the TEDS lintel design tool. Here you can see the basement wall or retaining wall. Again, some similar options here for codes and design sections. Again, this is looking at within a retaining wall or basement wall. It's just going to be looking at the stem as masonry. So as you see that we have both concrete and masonry selected, the concrete code is still going to be necessary for the foundation elements of the basement wall or retaining wall. But then obviously with the stem, we're going to be choosing to look at all the different forces that you can have on the stem and do a masonry design check for those elements. Next, I'm just going to give you kind of a really quick overview of what ENERCALC. Again, ENERCALC, like TEDS, is going to be a very nice tool for doing a lot of different designs, whether they be steel or concrete or wood. There's a lot of predefined design checks that you can make within ENERCALC. Masonry is also included here. You can see masonry walls, columns, masonry beams, all different options that you can utilize with ENERCALC. For the next slide, what I really wanted to do is, again, stack up some of the different options that we had talked about. You can see all the different material options from all the different programs. All of them really do give you an initial value for F''M, but allow you to specify the overall assembly or mortar type, mortar categories, all different things that are going to change the overall capacities. We can see different wall thicknesses that you can select and utilize for designs. We can see when we can do unreinforced wall checks. Again, that's going to be really important anytime we look at something like a partition wall, where we're going to have very low load demand on the design. So being able to do an unreinforced partition wall check is going to be important and a very good use of a component design tool. You can then see what you have for reinforced checks. Again, for shear walls, for in-plane axial and bending, out of plane bending forces. You can see all the different options that you'd want to utilize. Lintels, you can see very similar lintel option for each program, but you can see, again, the ELEMASONRY, QuickMasonry having the nice ability to do both vertical and horizontal spans and arching action, all really nice to be able to utilize. Next things to point out, again, with these different component design softwares, here we have a variety of different options that are available. You can see some overlap. You can see some that have some emphases. The different support conditions, you can see the Tekla TEDS program having a variety of different support conditions that you can utilize for the design. For the different programs from ELEMASONRY Direct Design, really looking at simply supported elements, sometimes with a parapet that can be utilized. But then under the loading conditions, you can see a few more options from ELEMASONRY, QuickMasonry, to where you can put a variety of different types of loads. Something like a vehicle barrier force that you would have, say, in a parking garage. Sometimes putting that horizontal line load might be really nice. So looking at that design with ELEMASONRY or QuickMasonry might be needed. The other thing that I do like to point out is TEDS does also give us the section design. So again, if you have some limitations to any of these, maybe we go to all kinds of variety of different support conditions, loading conditions. Again, if you do extract some different results from a finite element analysis, you can bring it into a section design. So then all of the different little kind of support conditions, loading conditions will be covered. The place where the component design softwares work really well is certainly with the coverage of the different codes that we utilize. So certainly the different programs from CMHA and CMA are going to give us really good options for codes, very well supported by industry. TEDS also is following suit with all the different codes that are going to be utilized. The direct design method is going to be a little bit different, since it's going to be following the different handbooks and the codes that are utilized to develop the direct design handbook. And so you can see the different codes available there as well. So again, just kind of in conclusion, we looked at a variety of different programs here. You can see some of the different options for component designs. Again, component design softwares can be very useful for designing partition walls, single-story buildings, low walls, regular shaped buildings, even with some relatively small openings. Again, you could see just even a small opening like the example that I have on screen. There is some differences, and understanding where those differences are actually start to make a big difference in the overall budget for a project or the overall use of materials. It's good to recognize, but again, direct design, ELEMASONRY, QuickMasonry, and TEDS all being programs that we utilize here at Force and would certainly recommend. I like to conclude all the different software presentations that we make with Get to Know Your Software. Anything that we showed in the presentation today certainly could change at any time. So get to know the code, how it's implemented in each software, understand capabilities, and more importantly, understand different software limitations, making sure that you're not trying to ask the program to do something it wasn't created for and it doesn't have an intention to check. Always have the loads in the software reviewed by a peer. Do a quick load check on the model with a hand calc is always really, really important. And lastly, always remember software is a tool. You're an engineer, so we certainly want to make sure that we're using the software programs responsibly. And then lastly, you can see some of the different guides available for that we talked about today. And then certainly if you have any questions, you can reach out to me at sam@forceconsulting.com. Thank you.